Hello, everyone, and welcome to this session, this Stranger Danger session, and this is a special session on cloud-native application security. My name's Simon Maple, and I run the DevRel group here at Snyk, and it's my pleasure to be able to give you this session here today. A couple of things before we start. You'll notice that we are in GoToWebinar, and you have the chat and the questions panels or panes in that control panel. Feel free to go ahead and ask any questions you like in either of those. I should hopefully be able to see both of those. If not, I'm sure someone will prod me and give me some of those Q&A or chat as we go. So feel free to let me know who you are, let me know where you are in the world, and we can have a good chat through there, and I'll give some call outs as well. This session, why don't we go through in a second. This session is going to be recorded, and is recorded, should I say, and this will be sent to you as well. The replay will be winging its way back to you after this session has concluded. With that, let's jump forward and go through the session. So what are we going to be looking at today? Well, we're going to start off with what cloud native applications are. Now, when we think about cloud native applications today, we actually look at a very different app to what we would have been developing 10, 15 years ago. And we can see here from this picture what a pre-cloud application would typically look like. And we would have a bunch of hardware, maybe some visualization, virtual kind of hardware on top. Some router config, VMs on top of that, a whole bunch of other things. But then we have what the developers are looking at. Everything below that, beneath that, is really looked after by our ops and our IT organization. So the developers care about going into an IDE, writing some code, pulling in some libraries, and that is what they see. That is what they're exposed to in their application. Now, when we think about how that maps onto what we consider today a cloud native or a cloud application, we can see that a lot more of the infrastructure has made its way into the application. And there are a couple of things here, and it's really about the ownership of the developer, the ownership of the code that the developer writes, maintains, and needs to secure has got a lot further down the stack. And that is because a lot of the platform, a lot of the infrastructure has made its way into code and config, and these are the kind of artifacts that a developer often writes, a developer checks in. These are the kind of artifacts that we will see in GitHub or whatever your Git repository of choice is. So now let's take a look at what we see. Well, we still have some virtualization under the covers. We still have our application code and our open source libraries that we pull in. But now we have a whole bunch of things like containers. We may have service meshes. We will have some orchestration, likely Kubernetes, which maybe some partly dev, maybe partly ops work through that. So there is an amount more that a developer needs to be aware of, needs to maintain, needs to create. And this is equally the kind of artifacts, the kind of work that a developer needs to maintain and secure. And it's important, just as we have done with QA tests and everything else, that a lot of this is done at the right time, and we'll talk about that a little bit more. So what does this mean? Well, our applications have changed. We need to change our culture, our technology, and our tool. Let's take a look at it from the software supply chain point of view, and let's take a look at the different areas that really constitute our app and where the risks come into play. So custom code, this is always the tip of the iceberg. This is the part of the iceberg that is above water. It's the part of the iceberg that we as developers can very, very clearly see. Okay, we can see this, there's nothing hidden underwater. It's in our IDEs, it's what we write, it's what our colleagues write. This is what we see. However, open source code, this has been with us for many, many years. And open source code, of course, you'll see a whole bunch of stats. Gartner tend to say around 80 to 90% of your code base is open source. So that's, sometimes you look at that stat and you think, wow, that's worrying. This is absolutely superb. It means we can write a small amount of custom code and make use of great open source libraries that are there, frameworks and libraries that we can use to rapidly develop our application. One of the things that we need to consider heavily here, though, is when we think about it from a risk profile, 80% of our vulnerabilities are found in indirect dependencies. So the known vulnerabilities that we care about here, many of them are in our dependency graph, sometimes very deep in there. And it's very important that when we use this open source graph, dependency graph of great content and great code, we make sure that it's the right libraries, that they're maintained well, that they're secure, that they have a good community behind it. So it's really important that the health of the open source code is looked at there as well. So what goes beyond that? Containers. Okay, so these days, when we think about deploying, whether it's as a developer doing something rapidly with test containers and a whole bunch of things, we look at these containerized images. Now, we look at where we can kind of get these, and there are hundreds and thousands of packages and public sources that provide us with these images that we can just go and grab. These are very user-friendly. We can build them, we can deploy them, we can scale them in very quick amounts of time. So that's containers, but then beyond containers, we look about how we go ahead and actually orchestrate that. You'll notice that more and more of our infrastructure is actually turning into scripting that we can kind of check in. Now, when we think about what kind of scripting this might be, it could be Kubernetes, it could be Terraform scripts, whatever it is. These are the kinds of things that we tend to check in and version control. So when we think about our iceberg of an application that we try and deploy as a unit, there is a huge amount of increased risk that we as developers need to be very not concerned but aware of. I'm concerned to some extent, but very aware of, and we need to make our decisions based on this knowledge. So we'll go into all of this in a little bit more depth. Let's start with application code. So your application code, 80% of it, as we mentioned, is open source. We have seen from reports, and this is the state of open source report, which we at Snyk do annually, we have seen a 2.5 times increase number of vulnerabilities, open source known vulnerabilities, just in the last 3 years. And of those, 78% of those are found in transitive dependencies. And what this means is that the dependencies that we pull in directly in our POM XMLs or our package JSONs, it's the dependencies that they further bring in, the libraries that they require in order to run. Those are the dependencies and beyond that actually contain the vast majority of the vulnerabilities. So let's take a quick look, and I'll ask some questions as we go here. So feel free to just drop that in chat, and hopefully I'll be able to see them. But we'll see. Last time I remember I couldn't quite see them, but feel free to drop them in chat as I ask. Okay, here we have a Java application. It's actually a Spring application that I wrote. We have about 3 files and approximately 80 lines of code. Just to give you a little bit of background on this, this uses Spring Data. I think it also uses, it's got some REST controllers in there, and I think it uses Spring Data REST as well. So around 80 lines of code. If we look at the dependencies, here are 7 dependencies, and you can actually see them behind. A few starters. We also have a HAL browser, and starter web, starter JDBC, all the typical ones. So 7 direct dependencies, and of course there's a dependency graph behind that. So my question to you is, how many transitive dependencies do you believe this application, when built, will pull in? So how many transitive dependencies? And those are the dependencies that each of these direct dependencies will themselves pull in upon a build. So I'll give you a couple of seconds to write that in chat, and we'll see how we get on. And if chat doesn't work, which I'm not sure it is working, I have about 100 people on, so I'm sure there are people typing right now, and I'm not sure I'm going to see them. So if not, maybe some of the Snyk team can ping me some of the questions. Oh, here we go, Grant, thank you. Yeah, so do it as Q&A then perhaps, and I'll be able to see it in Q&A. So Grant comes in at 200, not too far off. A couple in, okay, there's a couple of 10s, there's an 1,000. So let me go back here. 7 direct dependencies. 59 transitive dependencies. So these are dependencies that we pull in from those 7 direct dependencies. So we're looking at around 66 in total. A couple of other guesses around 100, 150. Okay, now my next question. This is always an interesting one, and let me actually pop out the Q&A because I can feel this is going to get big quick. There we go. Let me pop that out. Cool. I like Lucas. Lucas, your comment there. 7 times 7 times 7. Sometimes it does feel like that. How many lines of code are we now going to deploy? So this is the lines of code in our application, so the 80 plus all the lines of code in our direct dependencies and the lines of code in our transitive dependencies. How many lines of code do you think we're putting it into a production environment? So again, please use the Q&A there, and I'll be able to see it through the Q&A, and let's see what people think. People sometimes tend to either massively overestimate or massively underestimate here. So we'll see what people are saying. Okay, a couple in. We have one at 100,000. We have David there at 50,000. Any other final guesses before we over 200? That's a good guess, unless you're thinking over 200,000. 10,000 from Sebastian. Any other final guesses before I reveal? Let's go for it. 11,800. Unusually accurate there, but the actual answer is always just shy of 750,000. So we need to desperately consider and acknowledge the fact that what we write in our IDEs is not just what we deploy in our production environment. We need to recognize that where our vulnerabilities exist may well, of course, exist in our own code, but we really need to make sure that what we deploy is what we maintain and what we secure. And all of that open source goodness, as great as it is, we need to be very careful about our selection of it and also our maintenance and security of that. Okay, good guesses, good guesses. Okay, one of the big lessons learned, of course, was Apache struts, and the Apache struts has had many remote code executions in its time. The Equifax one was one of the ones that really made it into public knowledge, and you can see here the timeline and the speed at which exploits made it into the exploit database once the vulnerability was known, and how quickly attacks occurred. And this attack, and I'll show you this attack in fact, but this attack is one that happened in such a way that you could pretty much just hit a vulnerable endpoint. There is very little lead up you need, and you can do a remote code execution against that process. And then again, depending on how that process was run, if it was run as root, then you're a root user executing some remote code. A couple of lessons learned here. It's not just about detecting fast and responding fast. We need to do it again and again and again at scale. So the detecting fast, sure, that's great, but if we don't act fast, then we give these attackers enough time and space that they need to get into our systems. And then doing that at scale to make sure that as the hundreds of vulnerabilities that are coming through and thousands each year, we react to each of them as we need, depending on our deployments. So let me go over to, let me go in fact over to this application. Let me quickly sign up. Hopefully I haven't spent too long here. So Simon@snyk.io, feel free to email me and I'll tell you about my massively secure passwords. 1, 2, 3, 4, 5, 6. There we go. Let's sign up. Okay, here is my to-do list. Yes, thank you, Chrome. I know this is a bad password. Here is my to-do list. I can create a to-do if I wish. Here, I'm going to buy my wife some flowers. That's a nice thing to do. Let's do it on February 14th. That seems romantic, and I do need to make that high because this is 1970. It's almost over 50 years ago. Excellent. There we go. There is my to-do. I can click on About. And you'll see I'm using, not always you'll get quite such detailed information about what happens under the covers, but you'll see here we can see struts 2 is using a vulnerable version of struts 2, which is actually the same vulnerable to the same exploit that the Equifax hack was. So let me attack this site, which is an application running on Heroku, and let me show you how to attack that very, very simply. So I'm going to just quickly grab a new terminal, and I'm going to go into the Java Goof exploits directory, and in here, if you excuse my typing, in here there is a headers file which I'm going to cat, and you'll see, let me make that a touch bigger still. You'll see we have a content type here. And this is the content type which we're going to pass on any request to that vulnerable struts endpoint. Those of you with a keen eye will see that this is an illegal content type because it starts with a % brace and it ends with a brace as well. And with this illegal content type on a request, we're actually going to go through an exception path. And as we go through an exception path, Struts is going to be kind enough to try and format much of the exception data or much of the error data and be able to provide us a richer response to tell us why this is an error. Now, it does this using a library called OGNL, and OGNL kindly evaluates strings that are that exist between the % brace and another brace. So this is great because now when we try and parse this and when we try and provide this in a message, what we're actually getting is OGNL to start executing it. And as part of this, you'll see that one of the things that we're executing and creating is a new process builder, and we're going to pass in commands to that, which is in fact going to kick off a new bash terminal. And that bash terminal is going to run a command, which we're just kind of like putting here as a placeholder. But if you will see what I'm going to do in my struts exploit, and cat that. What I'm going to do is I'm going to run this command. Clear the screen and show you this command. We're going to cat that we're going to cat that headers file, and we're going to substitute the command placeholder for env. And env is a command that we can run and execute, which will provide us the environment variables on the system it runs in. And then we're just going to simply run a curl command. I'm not going to run that against my local host, but rather I'm going to send that to the endpoint here, the Heroku app endpoint, and there we go. And if I run that, bang, we get the environment variables on that system. So, you know, some people, I'm sure no one on this call, but some people put wonderful sensitive data in their environment variables, and you can see passwords, you can see API keys, you can see usernames, you can see config information. This is a great way for an attacker to get in and start learning more about the environment. But this is the first hack, as I mentioned, that that was used against Equifax. So wanted to kind of like show that one. And before we go into some more slides, I really wanted to kind of show you some hacks. So quick question in from Michael here. Do you find that the multiplicative factors you demonstrate are fairly normal? And this is looking back at that previous example, or was this a well-crafted worst case scenario? So yeah, let's go back to that example actually. And where was it? Here we go. So these 7 direct dependencies, these are very common Spring dependencies. So we have Spring Boot starter for data REST, JDBC, and starter web. These are very, very common and usual dependencies that any or most Spring applications would make use of. It is not unusual to have, well, in fact, I would say it would be unusual to have fewer than 50 to 60 transitive dependencies in a Spring application. So from that point of view, that is very, very normal. It is, I would say, unusual to have an application of 80 lines of code, but it's not going to grow to the similar scale as to what we see on the right-hand side here. Your mileage will, of course, vary significantly depending on your ecosystem. So what you might find is a greater number of transitive dependencies in the Node ecosystem with a fewer number of lines of code per library. But you're typically, you know, if we think about what percentage of your application is open source, 80% is a good figure to kind of go by as a guess. So that's hopefully answers that question. Okay, what about containers? So we've looked at your code. What about containers? Or sorry, should I say we looked at your open source code. What about containers? Well, Gartner have suggested that over 75% of organizations, global organizations, will be running containerized apps by next year, which is a very significant stat. This just shows the adoption. Containers haven't really been around too long in the grand scheme of things. So, you know, three-quarter usage stat there is very, very interesting. When we look at it from a security point of view, the top 10 most popular images that are available today on Docker Hub have more than 30 vulnerabilities each. And if you look at the top one, which is a Node image, that has, I think, over 600 right now. So there are a lot of vulnerabilities that we find even in the most commonly downloaded images. And over 3/4 of the top 1,000 Docker containers have severe known vulnerabilities. So we have to really recognize not just the numbers here, but also the threat that can pose to us, and it makes the decisions as to which images and which tags we use even more critical. So what about the infrastructure as code? Infrastructure as code is equally important these days, and it's something that's growing massively, and we can see over 2 million Kubernetes config files have been found, easily been found just by doing a GitHub search. This is publicly available. 250,000 Terraform scripts. The numbers of infrastructure as code config files that are created that contain issues, that are known issues, known insecure defaults, is going to be very worrying. And on the right-hand side, we can see some examples of these insecure defaults. Of course, it's every time you see someone deploy an insecure S3 bucket or something like that, and you see some news about it, it doesn't surprise us anymore. It's one of the most common ways of a misconfiguration that leads to a exploit or something like that we've seen. So this is a worrying area, and definitely one that as we develop it as developers, we need to think about not just does it work, can we ship it, but we need to think very carefully about the security of this, the same way as we think about the security of our code as well. So misconfigurations are on the rise, and in fact, this is a really interesting stat that the 17% of breaches are caused by errors in configuration, and this number has actually doubled from, I think it was actually the 2018. Maybe it was last year, but I think it was the 2018 number from this Verizon report. And you can see on the right-hand side there, yeah, it does look like the 2018 on there. The numbers of misconfigurations there massively on the rise, and a lot of this is because the config these days are being pushed into different hands, into developer hands, into config that we copy paste, that we don't necessarily secure. And this is how misconfigurations can easily happen. And it's actually a very simple fix in order to overcome them. But it's a case of that knowledge of, do we know what is an incorrect misconfiguration or not? So how do we fix this? Everyone has heard of the kind of like, there we go. There we go. So how do we fix this? And this is an important challenge, because security teams are already overwhelmed, and they're small in comparison to engineering teams, which typically you'll see, the 100 developers to 10 ops people to 1 security person, right? This is the current model that we live in today, and there's huge pressure to push code out very, very fast and update production daily or weekly. So how do we make sure that what we're pushing isn't insecure? And with these pressures, what we've seen in the past is security teams perhaps try and add gates in this pipeline to make sure that we're not pushing further vulnerabilities, or regressing into production. This is a problem because, of course, this slows down our development, and we can see here that a third of respondents to our survey here, the Snyk DevOps Insights 2020, consider security as a constraint to the ability to move fast and deliver software through that pipeline. But this is interesting because we also ask the same question. We also ask the question of who owns security, who should own security, and the vast majority, over 80% of people, think developers should own security. And this is not just of their code, but this is of everything that they create. So this then asks the question, well, how do we do this? And this is what the DevSecOps movement is about. Very similar to the DevOps movement of bringing ops closer to developers. This is the same thing about bringing security to developers. But we can't just say, let's shift it left, let's throw data at developers and expect them to fix it with this massive, list of thousands of vulnerabilities. We need to make it accessible by developers. And the key thing here is we need to empower developers, and we need to enable the security team to support the developers. The way we can scale security in organizations is through the developers, because the developers are there in numbers, and the developers are there at source, if you excuse the pun, but they're there at the start to build security in from the ground up. The security team need to educate, need to enable, and need to support the developers in making the right decisions and helping developers to do that at speed as well. So it's empowering as well as doing it at the right time. And empowerment can be done through culture as well as technology and tools. Okay, that's a lot of talking, right? Should we do some hacking? And I want to really, when I talk about hacking, I'm going to show you a few different ways in which we can look at the range, the platform of issues that we talked about, going from code all the way through to open source libraries, to containers, and all the way through to infrastructure as code as well. And I'll give you some demos, and we'll hack. Depending on time, we'll do some hacks for open source libraries, and we'll also hack a container perhaps if we have time. So first things first, let me log into Snyk. Everything I show you here, pretty much, yeah, everything I show you I think is going to be entirely on the freemium plan. So you're more than welcome to try this out if you haven't got an account. If you have got an account, do feel free to follow along as well. So I've logged into Snyk, and what I'm going to do is I'm going to go to my integrations page, and I'm going to log in. I'm going to import a project, and I have a number of ways I can do this. I can import it through my source code repo, through a container registry, and so forth. CI, IDE plugins, package repositories, serverless. I've got a whole bunch of different ways. I'm going to do this directly from my source code repo. I'm going to go into my own GitHub repo, and I'm going to import a project. Let me just wait a second while this looks through my GitHub repo, and I'm going to import Goof Kubernetes. Okay, and I'll show you how fast this is going to do this, because I know there's a number of different artifacts in this. And in fact, if I click view log while it's importing, you'll see it's already found a ton of things. In fact, that's already it. It's pretty much found it all. You'll see I've got some artifacts for Snyk code. I've got a number of config artifacts, YAML, JSON, YAML. I've got a package JSON, so this is my open source libraries. If I go back to my current projects, you'll see here I also have a Docker file. I have, and I can go through these now and start having a look at what is actually in my application and where vulnerabilities might exist. So let's have a look at the application first, and we'll start doing some hacks on the application. So I want to give you a quick look at this, and then after that we can go into where we will attack it. So this is my Goof application. It's a Node application. I can do things like let's buy some milk, and it adds it as a to-do. I also have an about page down here, which just serves some static content from the public directory. And that's all I'm going to show you. That is just what I've shown you there. Already has multiple vulnerabilities in there. And I'm going to take a look back at this and jump to my package JSON. So this is a Node applications or an NPM structure. I click on this, and you can automatically see there that we had 38 high sev vulnerabilities, 32 medium, and 6 low. This is an intentionally vulnerable application which we created, and it uses a number of dependencies. Here you can see 448 in total, and these dependencies are real-world dependencies that have known vulnerabilities in them. So we're using them at vulnerable versions by the look of it. So here you can see direct dependencies that have vulnerabilities. You can also see transitive dependencies of this direct dependency here that also has a high sev vulnerability. And I'm going to go over to a specific issue, and let's do a directory traversal. Here's a directory traversal. This directory traversal has a vulnerable module ST, and ST is being pulled in here at version 0.24. It does have an exploit associated with it, and it's fixed in version 0.25. So there's a remediation, and this is what I was talking about with empowering the developer, showing them the issue, allowing them to have the information that they need in order to fix it, and absolutely making that as easy as possible to fix. So you can actually see there is a prioritization score as well here, so we can work out which ones we want to fix first based on whether there is a fix, whether there are exploits available, whether it's how high the severity is, for example. And if I wanted to fix it, I can just, because we connected through GitHub, I can click this button right here, which allows me to, it's going to just run the test again, and it allows me to select which vulnerabilities I want to go ahead and fix, and then it'll automatically send a pull request over to GitHub for me. So my question, actually, I'll ask a question in just a sec. Let me talk to you a little bit about what a directory traversal is, and then I'm going to ask the question about how we're going to try and attack this application to perform a directory traversal exploit. I'm going to scroll down quickly and just click open a pull request, and it will automatically create that against GitHub for me. Now, a directory traversal is a vulnerability that allows us to traverse outside of a directory which we have public access to, and this could potentially allow us to view sensitive information on a server somewhere, or you know, break out of a space that we should be staying in. That's what a directory traversal is, and this will fix it, just going from 0.24 to 0.25. This isn't the biggest jump we could do. There are plenty more versions above, higher than 0.25, but 0.25 was the first version that had the fix in it. And as a result, Snyk will provide this pull request that pulls you up to the minimum version you need in order to fix this issue. If I come here, you'll see that the package JSON has moved from 0.24 up to 0.25, and that's going to be fixing our issue. Okay, let's actually start hacking. So my question is going to be, where would you, if you were an attacker, think about how we should attack this application? Any thoughts on what you would do to try and perform a directory traversal? Maybe even which page, which area of the page, and we'll go from there and see if there's any ways in which we can attack. Okay, there's a question. There's one option in from Chris here to say, can we type something into here to perform a cross-site scripting? Cross-site scripting is actually a different vulnerability entirely. So what we want to do is the directory traversal. So think about where the vulnerability could exist if we were trying to perform a directory traversal. So there's a couple more questions. Sorry, a couple more options in here. So yeah, Gusti correctly says // etc password. So where should we put that in, Gusti? Where's the place that we should put that in? I could try here if you'd like, but this isn't necessarily going to isn't necessarily interacting with the file system. We need to think about how we can interact with the file system. Question in from Lucas: what if there is a different vulnerability in the next step up of the package version? So I'll talk to you about that a little bit later, but the Snyk will automatically test pull requests and make sure that if you're trying to introduce a new vulnerability, it'll fail that as well. Okay, choose file from John. It's not quite that one, but I can see Gusti has it. The URL, and the URL we're actually going to pick out here is the URL that serves this. And I'm going to jump across to a terminal, and I'm going to curl this file, and you can see that we have the about there. And yes, Matthew, yeah, that was exactly what it is. This is the statically served file that we're going to be looking at here. If I was to try and do a / there and perform that, what do we get? Well, we're actually at the home page. We're actually at the home page at this stage, because you can see we're at the goof to do. In fact, this is my to do that I created. So what's happening is ST is a real life library that recognizes what a directory traversal is, and it tries to stop us. It recognizes we're doing dots here. So is there any way we can do this without typing dots? We're really close. This is almost like a representation way of how we can send it, how we can still perform this directory traversal, but without sending those dots. Any thoughts? Okay, we got it straight away. The answer is URL encoding. Normally takes a couple of goes for that, but URL encoding, absolutely right. That was Richard. So URL encoding, the URL encoding, shall I be mean? Can anyone know what the URL encoding is of a dot? That's probably a mean question, right? That's one that maybe separates the hackers from the developers there. But %2e. Many of you have probably seen the %20 when you try and type a space in a URL. This is exactly the same thing. It's a URL encoding. %2e represents a dot, and by sending a %2e rather than a dot, we circumvent the sanitization in the ST library, and as a result, bang, there we go. We've broken free of the public directory. We see the public directory. What would you do now as an attacker? Anything? Where would you want me to? Where would you want me to go? You know, think about it as an attacker. I want to learn about the environment. I want to learn about the application. What would you as an attacker do if you all of a sudden got access to this environment? Someone mentioned the Docker file straight away. So if I just add the Docker file straight on, we can actually start seeing what we're using here. We can see we're using Node. We're using what effectively the exact images of that Node image. We can see we're not using a user directive. So I'm actually in user root, and as user root, Matthew is asking me to go up again. So let's carry on going. We could actually go up and up and up and up and up all the way to the actual root. In fact, what was someone asked previously, who was it? The etc password. Gusti asked for the etc password before. Let's now see the etc password. And there we go. There's the etc password of the Docker container that I'm running this in. At this stage, we have access to whatever we want that root has privilege to, and what the file system allows us to. This is a read-only vulnerability, so that's why one of the reasons why the CVSS score is a little bit lower, and as a result, it's a medium. But like I said, that one upgrade from 0.24 to 0.25, that will automatically fix this issue. So that was an issue. Let me jump back here. That was an issue. If I go back to my project, oops, not that one, sorry. That was an issue with my, yeah, this is the one I want. That was an issue with an open source library. That was a known vulnerability in an open source library. What else could we look at? Let's take a look. Oops, sorry, I didn't want that. Let's go out to my projects and jump back in here. So what else could we see? Well, what about our own code? This is a little sneak peek that I've got because I've got a feature flag running, but this is a sneak peek into our Snyk code, which is the ability to look at our own code and scan our own code. So you can run, you can also get information about the code you write, the custom code you write, as well as the imports that you do from open source libraries. And we can see straight away, you know, exactly where we are in our code, exactly what the issues are. And this is telling us straight away that there is unsanitized input from the HTTP body and it's flowing into fine. So what we're doing here is we're getting a request object, we're getting information from that request body, and we're throwing that straight into the username variable on a user.find. So we're doing this as an SQL query. Without sanitizing that, if someone wanted to do an SQL injection by adding some additional things in there, which maybe closes a backtick, a quote, and then writes something else, gets back a password file or a user file, whatever it is, they could start to do that. So what we need to do is we need to perform some sanitization on this, and that's exactly what this pulls out. And of course, if I go into more details, I can see a huge more amount about exactly where the issues are and what this means. So there's a quick sneak peek into Snyk code. And this, of course, there are going to be many of these command injection as well when we're trying to do an exec on something that we're not sanitizing. So this is all we're doing is we check the item is of type string, we try and match it against a regex, and then we pass it into this exec without doing any sanitization. So that's exactly the same thing. Okay, so let's go back out. And we're going to go to what's next. So we've done our code, we've done our open source libraries. Now let's take a look at a Docker file. And a Docker file is really interesting because it's one of the easiest ways to pull in hundreds of vulnerabilities without knowing it, because we just grab someone else's from, and it doesn't really matter. We just want to get it to work, right? It's not the way that we need to choose a Docker file. And Docker file, first of all, if we look at the image that we're actually using here, we're using a node image base, a node base image. And this is the version we're using. This is how many vulnerabilities this base image has today. This is the severity breakdown of those vulnerabilities. And the key thing is to say, well, what is the fix? Again, don't tell me about what the issues are, tell me how I can fix them. So we can talk about major upgrades. Okay, what if I move to version 10, a specific version? That will drop me my vulnerabilities, not too many, but you'll notice the number of high set vulnerabilities that drops me. That's like 120 odd high set vulnerabilities. The next thing is some slims. If you can drop to a slim image, it really reduces what you're actually providing in terms of the number of packages and layers and a whole bunch of stuff. You can see we dropped right down to 74 vulnerabilities and 55 vulnerabilities, only 9 of which are high set. So this is what developers want. Not just the information, tell me how I can fix it, tell me how to fix it. Okay, also there's a whole bunch of stuff in here about the different packages and again, exploit maturity. And with this many vulnerabilities, the priority score becomes very, very important, right? So this is more about the container. How long have we got? A fair bit of time. Let's do a quick hack. I'm going to show you an application here. It's going to be a different application that I'm running in a container. And this is actually a container just running locally. This is an application which grabs a file and resizes it into a Twitter-sized photo. So I can choose a file here if I want, click resize, and it will provide me that I can upload to my Twitter bio. But let's perform some hacks. So over here, let's find a terminal that I want. Okay, here is the Docker file. Is the Docker. There we go. This is the Docker. I'm sorry. I've SSH'd into the Docker image, so I can see exactly what's happening on my machine. Obviously, as an attacker, I wouldn't have this, but this is just so we can see what's changing under the covers. A couple of other things that I wanted to show you. I've got some nice scripts here. I've got some netcat here as well, and I'll talk about that in just a second. What I'm going to do now is I'm going to come back over here. And I'm going to choose a file to resize. There we go. I'm going to choose RCE1, remote code execution 1.jpg. I'm going to click open, and in a second I'll click resize. But let's actually just take a look at what RCE1 does. And if I look at it, we can see that, okay, it's going to create a regular image. We're going to fill something with something in a URL. That URL is going to go oops.jpg, whatever, that's not going to exist. But what we're doing is we're actually terminating that string, and we're doing an OR on that, and we're going to touch RCE. So we're breaking out of this execution and executing something of our own. Okay, so this is almost like a code injection, right? And we're going to remotely execute RCE1. Okay, so let's go back one here. We don't see an RCE1 here on the Docker container, but if I click resize here now, well, image size can be success. Okay, we didn't really have anything to put there, but if I was to come back here and now take a look, now we have RC1 that exists on our Docker container. So now we've proved we can remotely execute things on that environment. Okay. Now let's have some fun. Now let's do something a little bit more interesting. So yes, let's do another. This time I'm going to choose RCE2.jpg. Okay, before I click resize again, let me go and have a look at this now. So, oops, wrong one. I want this one. Let's cat RCE2.jpg. That's at the top. Okay, this time what are we going to do? We're going to do something on an image over, and we are going to go to a URL. But hang on, this is an evaluation, right? This is the backtick evaluation. And on the backtick evaluation, when this gets executed, we're going to perform a wget to an internal port. So this is actually going to be going to my laptop. And we're going to grab r.sh. We're going to pipe that into a file. So we're going to push the contents of r.sh from this location into a local file called r.sh. We're going to execute that locally. And then we're going to touch a different file called A. Okay, so the file that we're going to pull from my remote machine is r.sh. So let's cat r.sh, and we'll see what we're doing. We're going to do a further wget, and we're going to pull netcat, this version of netcat file here from my exploits directory, which we're going to, obviously this could be a nasty URL, nasty website where it pulls all this from. In this case, it's just tunneling it down to my laptop. We're going to pull that. We're going to extract it. We're going to make it, configure it, and then run netcat and actually connect it to something on my machine on port 3031. Okay, couple of things that I need to do before we start then. I'll tell you what, let's go ahead and serve up everything in this directory. Okay, so now we are serving these files, okay, at port 5000, and that's exactly where the container is going to be trying to pull netcat from. So it's going to pull from here directly into the container. The second thing we need to do is provide, there we go, we're going to kick off a netcat listener right there on 3031. So hopefully when netcat extracts and starts running on the Docker container, it's going to connect directly to this machine. Okay, so let's try this. I hit resize. What it's going to do is it's going to grab r.sh from my machine. It's going to run it. It's going to pull netcat from my machine. It's going to extract it. It's going to try and connect out back to my machine. And what I have there as a listener is effectively going to be a reverse proxy into this machine. So let's try this. I click resize. You can see it's waiting for localhost, so it's doing something. Okay, you can see it's spinning over there. Let's go here. And in fact, before we actually type anything there, why don't we just quickly have a look on Docker? And this is a vulnerability. Many of you will have heard of this before. This is a vulnerability that exists in a package called Image Magic. Amazing vulnerability name, which is, I think it's Image Tragic. But this is the vulnerability we're actually exploiting. And you can see netcat is here. You can see r.sh is here. So it looks like this has worked. Let's see if here now in this listener, I can perform a reverse proxy. I can, I've done an ls. I can now es-ef. I'm effectively running a terminal in that machine under the process that my application is running. Okay, so that was a really nice hack. Question in, is rce1.jpg an actual image file? To be honest, it doesn't matter. It doesn't matter. And what you'll see is whether it is or it isn't, the fact that something runs under the covers is what I care about. I could actually make it an image file, and I could just, in the similar way that RCE2 was a correct image file, because all I was doing was adding a mouse over. Very often when you start seeing a whole bunch of different exceptions in your logs that you've never seen before, a good reason that could be is because something like this is happening. Okay, so this is quite classic, unusual log behavior that you might see from a potential attack. Okay, so let me, I'll tell you what I could do is I could just cancel that now, and hopefully now you'll see A there as well. So that was the touch A right at the end. Okay, right, so we have shown now 3/4 of the platform, right? I've shown container and container hack. I've shown SCA with the package JSON. I've shown your actual code, your custom code, and I've next show your config. So your YAMLs, your Mongo YAML, your Goof deployment YAML. Misconfigured config, something that's very, very easy to do, even in a Docker file or something like that. Not having a user means you use the root user, for example. It's a default, and if you don't configure things correctly, you can potentially open yourself up to giving users more permissions than you need, or providing more access than someone requires. So what do? Well, we run something like the Snyk IAC, which looks at your config, in this case looking at this YAML file, and providing input, providing you feedback based on that. And you know what I'm going to say, right? Developers don't just want feedback, they want remediations. They want to know how to fix things. That's how you empower developers. So what do we have here? We have an issue. The issue is the app farmer profile is not set up correctly. The impact, what is to a developer, how is this going to affect me, my application, etc. But then the most important bit, how do I resolve this? And the way to resolve it is I need to add this with an annotation of that or that. Okay, as a developer now, I can look at this, I can talk to my security team if needed, get their support. But as a developer, I have the information I need. Container is running without root user control. The issue is container is running with that. The impact, well, again, you provide privileges. You can resolve this by setting that to true. Okay, you see the impact, you see what the issue is, you see how to resolve it. This is a really core piece that has been I feel across many different teams, something that's been almost neglected from a security point of view, and I think it's being looked at more and more because of things like S3 buckets, for example. Actually, I'm not sure if we have any S3. No, nothing S3 in here. Obviously, this is a deployment YAML, but yeah, those typical things. The more we see these kind of things in the news, the more we actually put more and more focus on IAC style misconfigurations in our production environments. This is a core issue. So let's go over. I'll take some questions in just a second, so feel free to ask some questions now in the Q&A. And I just want to kind of like cover a couple of the key points that we talked about in this session. And just to answer another couple of questions from Nick and others and Amir, this session is recorded and will be sent to you later as well. So no problems with that. You can certainly watch it again as well as share with your teams. So the core premise behind this is developers are, the development groups are far larger than ops teams or security teams. And it is the development groups which need to scale security testing and be responsible and own the security testing for their applications. Their applications themselves will have changed. They'll have changed from 5 years ago, 10 years ago, 15 years ago into a more cloud native environment. And as a result, the developer responsibility for code has changed significantly. They're no longer just writing code in their IDEs and pulling in open source libraries, but they need to maintain and create more artifacts, including container artifacts, including IAC, configs and scripts, Terraform scripts, etc. All of this, it's just as important to write that as it is to QA that, as it is to security test that. And it's important that this is done as part of our pipeline, as part of our environment. Now, I'm going to show you in just in maybe 2 minutes or so how we as developers can also do that. I've shown you from a Git perspective how you can create pull requests, how you can fix things by sending pull requests over to your repository. You can also have Snyk automatically test every single night, and when issues are found or new fixes are available, we can automatically send pull requests to your repositories. And that means that if something is in production and you're not even going through your pipeline, you can automatically find a new vulnerability has been found. It exists in your production environment, and here's a pull request over to your repository. But what does a developer need? Well, a developer, let's say a developer is in Visual Studio here. Let me just scroll this down. Let's say developers in Visual Studio and they are in their application. Well, this is the Goof application, in fact. And what you can see is the ST library, which is the one that we hacked earlier, is being used in this application. If I scroll there, you can see that the vulncost plugin is actually giving us live feedback about where vulnerabilities exist in our application. So there are apparently 4 vulnerabilities in ST, and this isn't just ST, but it is also the dependencies that ST pulls in. So I can click this, click my little bubble there, click fix vulnerabilities, and if I scroll up here on my output, I will see the vulnerabilities that exist in my direct dependency, which is ST, and then also the vulnerabilities that exist in the transitive dependencies of ST, plus the remediation I need. And as a result, I can come here to my package JSON, and I can find the ST, and you'll also notice that this also comes up as a little squiggly line under there, and I can update this to 122, retest, rebuild, run my tests, and merge from there. So we think about this as a developer in our IDEs. We think about it as well if I was to come back out as in a command line. Where am I? Here. I can also run Snyk test here on the command line. And this will automatically give me that same information back. Where are my vulnerabilities? Give me some information about my vulnerabilities. Tell me how to fix my vulnerabilities. If I upgrade, from this to this, these are all the vulnerabilities I will fix. Again, here's the ST. In fact, these are the 4 vulnerabilities I will fix if I go from 024 to 122. So it gives a very security remediation view of the application. Okay, couple of things that I also wanted to talk about, which is CI. CI is an important area which we obviously use as a way to potentially block a job going through our pipeline into production. You could run the command line interface as well through the CI, or you can choose to run using one of our plugins. If you use our plugins, you obviously have the nice UI that you can select, and it's fully integrated with your CI systems. If you choose to use the CLI, you can run something called Snyk Monitor. And what Snyk Monitor does is it provides a snapshot. And this snapshot, if I was to click on it, will look at my previous runs as well as our current one, and will fail if we have new vulnerabilities that didn't exist on our previous runs. And what this allows us to do is only fail builds if we are introducing a new vulnerability. And this is something that I'll also show you in the GitHub pull requests as well. But if I was to click on this snapshot, in fact, let me just switch screens, because here is the actual screen that it popped up. This is now the source's CI rather than GitHub, and this provides me with all the same information, all my vulnerabilities. So let me very quickly just go back to GitHub, and the last thing I want to show you, and I'm almost at time. Sorry, I'm going through this at speed at the last minute. But what I'm going to do is I'm going to go to my Goof application, and I am going to look at my pull requests. And I'm going to pick the pull request here. Let's say this pull request is going to upgrade Mongoose from version 4.24 to 5.11.7. And if I was to scroll down, one of the things that you'll see here, and this is one of the questions that was asked a little bit before about if you were going to introduce a new vulnerability as a result, what this will do is it will test the delta of that pull request and see if new vulnerabilities are being included, either security vulnerabilities or licenses against our policy. So this makes sure we never regress. Okay, we're pretty much at time. I'm sorry, there's a lot to fit in. I could show you a lot more, but I want to just thank you all for your attendance. Thank you all for your questions and your interaction, and I'll see you next time. This recording will go out to you again very shortly in a communication. Thanks, and feel free to go to snyk.io to either create an account or to find more information about some of the tools that we have. Thank you very much.